Alright guys, just a quick video on sectional density. If you don't already know what that is, you should look into it. Ed Ashby wrote a little bit about it in his aerophysics documents that he published years ago, probably 20 plus years ago. And one thing that he mentioned that I learned is pretty important, was looking into it more. There's a lot of information about bullets, but not so much arrows, and that's sectional density. It's basically the weight of an object divided by its cross-sectional area. So the diameter of an object, like this, divided by how much it weighs. So obviously, if this was the diameter of this dowel, the same, but it was shorter, like to here, obviously it would weigh less from how long or how wide the diameter is, and therefore would not have a very high sectional density. But if you keep that diameter and you elongate it, it's going to have a greater sectional density. You could take it even further back, it's going to have even more sectional density. And what that means is how much force is applied to that smaller diameter. So if it's a really heavy object, but that's how large the diameter is, there's a lot of force applied just in that surface area, that diameter. Now this is very interesting. We take this is a 3/8 inch diameter rod of steel I picked up from Home Depot, and this weighs about 8,000 grains, and I'm sure they're about the same weight. This one might be a little lighter. But if I was to throw both of these at you, you probably want to get hit with this one and not with this one. Because this, even though it weighs more, even if it weighed less, it would still hurt more because of the smaller frontal surface area that force is concentrating on. So if I were to throw both of these, this one would go way deeper into you, penetration-wise. This may would probably most likely just bounce right off you. So when you're thinking about arrows, it's important to recognize not just weight, but how big of a surface is that weight concentrating its force. And so sectional density is a huge factor as far as what you should be looking for in regards to penetration. And as far as I can tell, the greatest sectional density that an arrow has to offer is a micro diameter arrow. Because let's just say this is a micro diameter arrow and this is a huge target arrow diameter for the sake of argument. Look at how much more penetration power you're going to get in something that's heavier and smaller in diameter. Now granted, you could always make a larger diameter arrow heavier than a micro diameter arrow. Like these, this is a 300 spine, 0.231 outer diameter. And it's quite a bit smaller than this 3/8 inch diameter. But if this weighed 2,000, 3,000 grains, it would have better penetration power than even this 3/8 inch diameter beam here. So that's interesting to think about as far as aerophysics when you're looking to buy a hunting arrow or target arrow, etc.